Hello everyone, welcome back to Pre-Algebra. In our last lesson, we talked about commutative and associative properties of addition. We applied them to do a few addition problems, and we also looked at a few involving mixed computation with subtractions as well. So in today's lecture, we're going to look at three arithmetic properties of multiplications. The first two being the same, commutative and associative properties of multiplications. And the third one is distributive property. Before we dive into these new properties, let's take a quick recap of multiplications. So we all know by now that multiplication is basically repeated addition. So for example, 5 plus 5 plus 5 is essentially 5 added to itself 3 times, which is 5 times 3. Okay. And if we use a letter A to represent any number, then A plus 8 is essentially A added to itself 3 times, which is 8 times 3. Okay? And let's look at a few different ways to mathematically write multiplication. So the first way is using the cross, like what we just looked at, 5 times 3 or 8 times 3. Okay? So the second way you'll see is using a centered dot to represent multiplications, like 5.3, which means 5 multiplied by 3, or using 3.8, which is 3 times 8. Okay. And another way you will see more and more often in pre-algebra or algebra later on is to use nothing. So as strange as it sounds, if this is the first time you encountered it, so 3 times A can be written as 3A together with nothing in between. Or if you have letter A represent a number and letter B representing another number, then A times B is simply AB. Okay. Now be careful that this format cannot be used on multiplying two actual numbers together. So for example, 5 times 3 cannot be written as 53. Okay. It can be easily mistaken as 53. Okay, now let's dive into today's first property, commutative property of multiplication. It says, changing the order of number we are multiplying does not change the product. So if I have two letters, A and B, represent any numbers. So A times B is the same as B times A. So another way to understand this is in an expression with only multiplications, it does not matter which number we multiply first. We will always get the same answer if we multiply the numbers in any order. Okay? So let's go to the board and use some illustrations to understand this better. So let A and B represent any two numbers. Commutative property says A times B gives the same result as B times A. So let's use an actual example with numbers to get a more intuitive understanding of this. Let's pick, say, A is equal to 2. Okay? And let's pick B is equal to 4. Okay? So in our example, A times B becomes 2 times 4. So we have 2 times 4, which is equals to B times A, which in this case is 4 times 2. Okay? So let's look at the left side first. 2 times 4, which we kind of already know this from when we learned multiplication, means that there are 4 groups and each group has 2 elements. So we have 2 elements in one group and there are 4 such groups. The third group, this is our fourth group. So in here we have 4 groups. Now let's look at the right side. Right side is 4 times 2. It has 2 groups and each group has 4 elements. So each group has 4 elements and there are 2 such groups. Okay. So here we have two groups. Okay. So now if you look at the left side, the total here is 8. And if you look at the right side, the total here is also 8. Okay. So both sides has the same result. This illustrates the order of how the numbers are multiplied does not matter. They all gives the same product. So let's look at the commutative property with a few practice problems. Our first problem of the day, 4 times 7 times 5. If we multiply from left to right one by one, 4 times 7 will give us 28, and this multiplied by 5 gives us 140. So let's put 140 on the top right as a reference. Okay. Now let's use commutative property and try to solve this problem again. So we first switch the order of 5 and 7 using commutative property. That gives us 4 times 5 times 7. And the results should still be the same, so we put our equal sign. Now here, from left to right, it becomes 20 times 7, which equals to 140. So applying commutative properties give the same 140 from our first method. Okay. Let's look at another similar problem. 8 times 6 times 5. So if we compute this using order of operation from left to right, 8 times 6 gives us 48. And that multiplied by 5 is 240. Okay. So let's put down 240 on the top right as a reference. Now let's use commutative properties and switch the order of 6 and 5. This will give us 8 times 5 times 6, okay? Which is 8 times 5 is 40 multiplied by 6, and that gives us 240. Okay? So the answer is the same as what we had before. If you notice in the previous two problems, after applying commutative properties and then doing the multiplication, both times we got numbers with trailing zeros. If you remember from our previous lecture, we talked about we like numbers with trailing zeros because they can make the calculation easier and faster, sometimes significantly. So let's keep this in mind and let's take a look at this problem. So let's first compute this from left to right following the order of operations. So we first do 8 times 14. This will give you 112. Now take 112 and multiply by 25. If you use a scratch paper and work out the multiplication verticals on the side, the answer you will come up with is 2,800. Okay? So let's keep that in mind on the top right. The answer to this is 2,800. Okay? Let's try to solve this problem again using the commutative property this time. So let's first switch 25 and 18. Switch these two around. So this gives us 8 times 25 times 14. Okay. So now 8 times 25 is 200. Okay. If you need scratch paper to work this out, the recommendation is to memorize it. So we have 200 times 14 copied down. So now this calculation becomes much easier to compute, which is 2 times 14 is 28, followed by 2 trailing zeros coming from the 200. Okay? So the final answer is 2,800, which is identical with what we have previously. So we talked about commutative properties. Let's take a look at the associative property of multiplication. It says in a multiplication expression, regardless of how the number factors are grouped, the product will always remain the same. Let's take any three numbers represented by letters A, B, and C. Associative property says, first, multiplying A and B together, then multiplied by C gives the same result as multiplying B and C together first, then multiplied by A. Now extend this further. Instead of 3 numbers, if we have 4 numbers represented by letters A, B, C, and D, commutative property says that A times B times C times D gives the same result as multiplying B and C first together, then do the rest in order, which is also the same as multiplying C and D first together, then do the rest in orders, and then so on and so forth in any combinations. So the word associate is essentially grouping, and grouping is essentially using parentheses. Let's take a look at a few example problems to help us understand this better. In this first example, 70 times 40 times 50. If we follow the order of operation and compute from left to right, the answer you eventually reach is 140,000. So let's just keep that on the top right as a reminder. Okay. Now let's use associative properties to attempt this problem. We're going to first group 40 and 50 together by putting a parentheses around them. So this becomes 70 times parentheses 40 times 50. Okay. So we're going to compute what's inside the parentheses first, copying down the rest. 40 times 50 is 2,000. Okay. Now, 70 times 2,000 gives us 140,000. Okay. So the result is the same as before. Now let's take a look at this problem. Same practice. Let's first compute it from left to right in order. If you work out each multiplication one by one, you eventually get the answer of 600,000. Okay. So let's attempt this using associative properties. Take a look at the numbers here. You'll notice several 2-digit and 3-digit numbers. Okay. So I spotted 125 and 8. And we're going to use associative properties and group these two numbers together and compute them first. So this becomes 25 times parentheses 125 times 8 times 4 times 6. Okay. So why group these two together? That's because 125 times 8 is equal to 1,000. And remember, we mentioned previously we like numbers with trailing zeros because they help make the computation easier and faster. If you do not know 125 times 8 equal to 1,000 by heart, then the recommendation is to memorize it. It will come very handy. So moving on, this becomes 25 times 1,000 times 4 times 6, which is 25,000 times 4 times 6. Okay. So here we have 25 times 4 is 100, with 3 more trailing zeros from the 25,000. Okay, so this becomes 100,000 times 6, which is 600,000. Okay, same result. Let's do a few practice problems. Pause the video and try to solve this problem using commutative and associative properties. Now, if you have solved it by multiplying these numbers from left to right in order, pause the video and try again. Look for numbers that when multiplied together gives you a product with trailing zeros. So here I see a 2 and a 50. I'm going to use commutative properties to switch 2 and 78. By doing so, the 2 will be placed next to the 50. So this becomes 78 times 2 times 50. Now I'm going to use associative properties to group 2 and 50 together and do the multiplication on them first. So this becomes 78 times parentheses 2 times 50 parentheses. So this becomes 78 times 2 times 50 is 100, which is 7,800. Okay. So looking back, in here, we used commutative property. Okay. And in this step, we have used associative property. Now pause the video and try to solve this one using commutative and associative properties. Note that in this problem, a center dot is used to represent multiplications. So in this problem, if you become very familiar with the commutative and associative properties, you can quickly come to the answer of 34,000. Let's see how to achieve that. So here I spotted a 25 and I also spotted a 4. I know that 25 times 4 is equal to 100. So I'm going to switch the order of 25 and 17. So 25 is placed right next to the 4. And this becomes 17 times 25 times 4 times 20. Okay. Next, I'm going to use associative properties and group 25 and 4 together and compute them first. So this becomes 17 times parentheses 25 times 4 parentheses times 20, okay, which is equal to 17 times 100 times 20. Next, I'm going to use associative property again and group 120 together to compute them first. So this becomes 17 times parentheses 100 times 20 close parentheses, which gives 17 times 2,000. Okay? And the answer is 17 times 2 is 34. There's 3 trailing zeros coming from the 2,000. So the answer is 34,000. So let's do a quick recap. So in this step here, we used commutative property. And in this step here, we used associative properties. And in this step here, we used associative properties again. So far we've talked about commutative and associative property of multiplication. Let's take a look at our third property of the day, distributive property. Distributive property of multiplication says, multiplying a sum by a number gives the same result as multiplying each addend by the number and then adding the products. Okay, this might sound confusing if it's the first time you're encountering it. So let's take a look again. It says, multiplying a sum by a number is the same as multiplying that number to each addend and sum the products together. Okay? So the idea here is when we have a number multiplied by a parentheses grouping another set of numbers, then it is the same as we take this number and then distribute the multiplication into each element inside the parentheses. So here we have A is distributed into B, which gives A times B. A is also distributed into C, which gives A times C. And the product of each is added together because it's originally a summation. Okay. So you might ask, what if it's a subtraction inside the parentheses instead of addition? Okay. So if it's a subtraction, it can be distributed in the same manner. you can subtract the numbers first and then multiply, or you can multiply and then subtract. Okay? So in subtraction, the A is also distributed into each element inside the parentheses. So it becomes A times B, and then A times C, and the two are subtracted because the original problem is the subtraction. Okay? So let's again do a bubble illustration to help us understand this distributive property better. So let A, B, and C represent any three numbers. And the distributive property says A times B plus C is the same as A times B plus A times C. Now let's use actual real numbers to substitute for the A, B, and C. So let's pick A is equal to 2, B is equal to 3, and C is equal to 4. Okay? And we're going to substitute these numbers into the expression. So on the left side, we have 2 times 3 plus 4. And on the right side, we have A times B is 2 times 3 plus, and then A times C is 2 times 4. Okay. Now, let's take a look at the left side first. So the parentheses gets evaluated first, which is 3 plus 4 is 7. So this is saying we have in each group 2 elements, and it occurs 7 times. So this is our second group, third group, fourth group, fifth group, sixth group, and seventh group. Okay, so here in total we have 7 groups. Okay, so how many bubbles do we have in total? The total we have is 14 bubbles. Now let's take a look at the right side. 2 times 3 gets evaluated first. So this means that in one group we have 2 elements, and this occurs 3 times. This is our third time. And in here we have 3 groups. So the total bubbles we have for this one is 6. Then we evaluate 2 times 4, which is also one group has 2 elements and it occurs 4 times. So it's the third time and our fourth time. Okay. So this is 4 groups. And the total number of bubbles here is 8. And now we combine these two. This gives us 14 bubbles total, which is the same as what we have on the left side. Okay. So if you look at this illustration and compare the left and the right side together. So on the left side, we have 2 elements in one group multiplied 7 times in one shot. But on the right side, we have 2 elements in one group multiplied 3 times and 4 times separately, and then combine them together. So now if you take this set of bubbles here and then move it underneath this set of bubbles, okay, you can kind of start to see that the bubble pattern is exactly the same as what we have on the left side. Okay. So it becomes a bit more clear in this illustration that the distributive properties splits up multiplication problems into smaller ones. So sometimes this kind of splitting can help simplify our calculations. And we're going to see this in an example coming up. So by now we know this is distributive multiplication. Now let's reverse this expression by moving the stuff in the right side of the equal sign to the left and moving the left side to the right. And it becomes like this. So here we start with A times B plus A times C. You see there is A in A times B and also A in A times C. The key here is to find that common number or term in each operand, pull it out on the side, and then group the remaining non-common ones together and keeping their original sign. Then finally multiply the two together. So we have A times parentheses B plus C close parentheses. This sometimes is also referred to as the factored form or factoring out the number 8. Later on, you will see or hear this term more and more often. So for now, let's do a few problems to help us get familiar with this. And keep in mind that this factoring form is essentially just the reverse of distributive property. So let's look at an example using distributive properties. A times parentheses 125 plus 9 close parentheses. If we look at this problem, it's really just a multiplication problem. It's one number multiplying another group of numbers added together. And this meets the criteria that we can use distributive properties. So we're going to distribute the 8 into each addend inside the parentheses. Okay? So this becomes 8 times 125 plus 8 times 9. Okay? So 8 times 125 is 1,000 plus 8 times 9 is 72. This gives the answer of 1,072. Okay? So why sometimes we want to use distributive properties? Because by using distributive properties, you can split a multiplication problem into two smaller problems and then add the results together. So sometimes splitting into smaller problems can simplify the calculations, such as in this example. So in this problem, you probably saw that we have the product of two multiplications added together, and the number 25 is common in both. So we're going to factor the 25 out. And this gives us 25 times parentheses, and we're going to group the non-common terms together. And the non-common ones are 9 and 31. We carry over the original sign. So it becomes 25 times parentheses 9 plus 31 close parentheses. So did we do this right? We can always use the distributive property on the factored form to see if we can get the original. So if we use distributive properties on this one, it becomes 25 times 9 plus 25 times 31, which is the original problem. Okay, so we move on. 25 times 9 plus 31 is 40. And this becomes 100 plus one more 0, which is 1,000. Okay, so the answer is 1,000. Now take a look at this problem. We again have two multiplications resulting in two products, but this time they're being subtracted from one another. So if we attempt the factorization method, the answer can be very quickly computed, and it is 987. Now let's do it step by step first and see how that came about. Okay. So in factoring, we look for common numbers. So you notice that 987 is common in both operands. So we're going to take that out and put that on the side. So it becomes times 987. Then we're going to group the remaining non-common ones together. So parentheses 123 is left here and 1 minus 122. Okay, so the minus sign is carried over from the original. So this becomes 123 minus 122 is just 1 times 987, and the answer is 987. So using factoring, try to attempt this problem yourself first by pausing the video. Note that multiplication here is also represented using a centered dot. So in here, you probably already saw that number 13 is a common number in each addend. So we have a 13 here, we have a 13 here, and we have a 13 here. So we're going to pull that out and then group the non-common ones. So we're going to pull 13 out and put it on the side, and we're going to group the remaining non-common ones together. So in the first addend, 18 is what's left over, plus in the second addend, 50 is what's left over, and then plus in the third addend, 32 is what's left over. Okay, so we have this expression. Next, now let's use the commutative property of addition from our last lesson to switch the order of 50 and 32. And this becomes 13 times 18 plus 32 plus 50. Okay, so why do we do that? Because 18 plus 32 gives 50. So it actually becomes 13 times 50 plus another 50. Okay, now this becomes much easier to compute. It becomes 13 times 100, which is 1300. Okay, so this concludes our lesson today. We talked about three properties: commutative and associative properties of multiplication, and distributive properties. So by now you know several arithmetic properties. I hope that you have learned and understood these properties. And beyond that, more importantly, the goal is to use these properties to help simplify the calculation so you can compute the results faster and less error-prone. Okay, so that concludes all of our lesson today, and we'll see you next time.